Carbohydrates or saccharides. Carbohydrates are organic molecules made up of carbon, hydrogen, and oxygen, with the general formula for most carbohydrates being CnH2nOn. Carbohydrates are classified into three main groups: monosaccharides, disaccharides, and polysaccharides, depending on the number of basic sugar units they have. Three main groups: monosaccharides, one subunit; disaccharides, two subunits; polysaccharides, many subunits. The most popular subunit is glucose. It has 6 carbons. There are some types of monosaccharides depending on the number of carbon atoms in the molecules. For example, 3 carbon sugars, 5 carbon sugars, and 6 carbon sugars. 3 carbon sugars or trios, such as glyceraldehyde; 5 carbon sugars or pentose, such as ribose, deoxyribose; 6 carbon sugars or hexose, such as glucose, fructose, and galactose. Deoxyribose is a sugar of DNA. Ribose is a sugar of RNA. You can see 5 carbon sugar in the structure of DNA. Monosaccharides are the most basic units of carbohydrates and are the simplest form of sugars. Glucose, fructose, and galactose are units forming disaccharides. Disaccharides are formed when 2 monosaccharides undergo a condensation reaction. Maltose, formed by 2 glucose units. Sucrose, 1 glucose, 1 fructose. And lactose, 1 glucose, 1 galactose. Do you know what makes sweet taste for the fruits? Monosaccharides, disaccharides, are the main ingredient that make fruits sweet. Sugar content of common fruits: the sweeter fruit, the higher sugar percentage. Lactose and galactose are found in milk. We call it milk sugar. Energy is stored in the chemical bonds within the molecule and released during cellular respiration. This process usually uses simple sugars such as glucose. Glucose is the center of metabolism in the most living things on the earth. Glucose can make energy, other sugars, protein, cellulose, starch, and many other molecules. Polysaccharides include starch, glycogen, and cellulose. They are long chains of glucose molecules linked together in condensation reactions. Each chain may contain thousands of glucose molecules. Starch, subunit alpha-glucose. Glycogen, subunit alpha-glucose. Cellulose, subunit beta-glucose. Alpha-glucose and beta-glucose differ in the orientation of the OH group of the carbon number 1. Now let's pay attention to the group of C1 and C5 of alpha-glucose. They are on opposite faces of the ring, but you can see they are on the same face of the ring in beta-glucose. Making alpha-1,4 glycosidic linkage. Making alpha-1,6 glycosidic linkage. This is the linkage to make branch. Making beta-1,4 glycosidic linkage. In starch, the alpha glucose molecules are linked together in long straight chains, amylose, or branched chains, amylopectin. Amylopectin creates the stickiness of starchy foods. Starch is the storage molecule in plants. Alpha-1,4 glycosidic linkage in straight chain. Alpha-1,6 glycosidic linkage at the first position of branch. In glycogen, the alpha glucose molecules are linked together in highly branched chains. It is a storage molecule in liver and muscle of animals. Starch stored in plant cells, glycogen stored in animal cells. This is because they are insoluble in water and do not affect water potential in cells. They are too large to diffuse out of the cells and thus remain within the cells. They have a compact shape that saves storage space. They can be easily hydrolyzed into glucose for cellular respiration. Cellulose is found in cell walls of plants. Beta-glucose is subunit of cellulose. It's linked together by beta-1,4 glycosidic linkage and always unbranched. The long straight chains of glucose are linked together by hydrogen bonding to make cellulose fibers. Let's take a closer look at the beta-1,4 linkage of cellulose. Every beta-glucomonomer is upside down with respect to its neighbors. See the highlighted OH groups, making the linkage very strong, so cellulose is the top material. You can see starch, glycogen, cellulose are all made up from glucose but have different characteristics. Why? It depends on the type of linkage and quantity of branch they have. Chitin. Animals such as arthropods building their exoskeletons using chitin. Chitin is also found in the cell walls of fungi. Exoskeleton includes chitin, protein, and pigments. Chitin is a kind of polysaccharides, but different from others. Its unit is N-acetylglucosamine that contains glucosamine and an acetyl group. Sources of chitin. Test for reducing sugar and starch. Test for reducing sugars using Benedict's reagent. Benedict's reagent contains copper-2 sulfate, blue. Reducing sugars can reduce copper-2 ions in Benedict's solution to copper-1 in the form of copper-1 oxide, Cu2O, a brick red precipitate. Procedure: take 5 ml of Benedict's reagent, add 8 drops of carbohydrate solution, boil over flame or in a boiling water bath for 2 to 5 minutes. Let the solution cool down. If there are reducing sugars, the color of the solution will change from blue to brick red. Negative reaction, positive reaction. Reducing sugars such as glucose, fructose, galactose, maltose, lactose. Test for starch using iodine solution. Procedure: add a few drops of iodine solution to the sample. If the sample contains starch, it will turn blue-black in color.